Alright, picking right up where we left off from the last video, we're going to go into detail here, and I'm going to kind of explain what all is going on in this level blueprint that's pulling off this trailing decal effect. So on the begin play, we're going to get the player character, we're going to save it. We're going to also add that point to an array. We don't technically need this, but it's just good to have for right now. Or eventually whenever I make some modifications. And then we need to know the lifetimes of our decals, so we're going to be incrementing and decrementing them, so we need to know that. And then we also need to know when they've reached their max size, and that'll be the kind of cue to flip it around and start decrementing them so that they kind of swell up and then they fade out like a bell curve. So we come in and we're going to get the player location. We're going to break that vector. We only want the x and y, and then we're going to shoot downward to negative, infinity on the z-axis. Basically, we're looking for the floor. Realistically, you would want this to be like, maybe minus, I don't know, we'll say 150 or something. That way, if you're falling from the air, it's not going to spawn something on the ground way below you. But yeah, we're looking for world static. I just throw in ignore the player character just for safe caution there, even though the player is not a world static. So, and then we're going to take that hit location and we're going to spawn a decal. And I set in the default kind of size here, which is kind of like what was in the viewport here. This base decal, if I can select it. Where'd it go? Oh, there it is. This one spawns out at 128, 256, 256. So I kind of put those same numbers in here. We're going to be working with scaling, not with the actual decal size. So then on tick, this is an absolutely terrible way to do this, by the way. On tick is just, that's god awful. Realistically, you could probably pull off, you would want to start, I don't know, like a function by name. We'd do one of these, and you'd probably, you'd want to come in and set a timer here, so it only does it maybe like once every 0.1 seconds. You would do it that way, and then you would create some kind of custom event. You would call this run loop, I don't know. And then you would put this in right here. And so every 0.1 seconds, oh, whoops, you wouldn't want to do this here, my bad. You would do this up here with the begin play. After all this, so you would want to put this all the way back over here, and you would, you'd run it this way. This would be how you technically want to do this. On tick, that's a pretty big no-no there. So let's double check it. Yep, still works. I'd have to change the numbers around a little bit with the timers, but for now I'm just gonna go ahead and use the event tick. So we come in and we set our player's current location, and then what we want to do is we want to set that. We want to compare that to the previous location. So yeah, technically, so the last index of that point array, we're going to compare it, and then we're going to get the length, and then we've got a threshold here, which mine's set for 50. Realistically, you might change this to something bigger for performance reasons, like every 100 units that you've moved from one point to another, like tangential, or not tangential, like a hypotenuse of a triangle. You're not talking like making a big curve. No, we're talking straight bird's eye line. So if you have moved more than that, then we're going to go ahead and add another point to the timeline, the lifetimes array. We're going to add that current location to that point array. We're going to add in a slot for has it reached max size yet, and we're going to default that to false. And then we come in and do the same thing. We do that same trace. I mean, you could throw this into a function realistically, and then we spawn another decal, and then we enter into this loop. So for each point, and I do a reverse on this. For this case, you could use a regular one because I'm not removing anything from here. I'm waiting until the end to do any removal because it just throws in all kinds of spanners into the mix. I don't know. It's annoying. And we're gonna check. We're gonna save its index count, and then we're gonna check to see if that individual point in this array, we're going to compare its slot. So if this was like slot 3 in the array, it's going to have a matching item in this has it reached max size yet array. They're going to be paired with each other essentially. It'd be great if, boy, I guess you could make a struct or something like that. A struct would do it too. But for this case, like I said, this is an early version of this. I haven't optimized it or streamlined it at all. So basically what we want to do is we want to check, have we reached our max size yet? And if we haven't, then we're going to come down and we're going to add, this is where you would change this right here where it says world delta seconds. You would put in the time that you used on your timer here. You would promote this to a variable and call this, I don't know, timer tick, something like that. And you would use that down here for your incrementing and decrementing to do this right, so it scales with time. Because if it's ticking at 1/10 of a second, then you want to add 1/10 of a second to this. But for world delta, this is for if you're using tick. So so we add time to that current index of that slot for that decal. We add some time to it, and we set that array element at the current index, and then we come in and we do a branch check. We see are we over our maximum time life or lifetime, and if we are, then we set it equal to the maximum lifetime. And then we check to see, we check our array and we see, are you the most recent array? This is important. This will mean that you'll never, the most recent one's always going to be the one under your feet. So we're going to compare that, and if it isn't true, meaning it's a different one, then we come over here and we're going to set its relative scale. We leave the x-axis, this is the z-axis technically on the decal, we set that just to whatever, that's just kind of like the max height. But we go in and we take our current lifetime and divide it by our maximum, and this gives us a percentage, and I'm just using a range map here from 0 to 1, from 0 to 1. 0 to 1 in, 0 to 1 out. You could set this to 3 or something. So when this is 0.5 coming in, this would be 1.5 going out. But for this case, I'm just using a 1 to 1. That leaves you room to play with it later. So then let's say that this isn't the initial decal, or the most recent decal. Then if it reaches max size, then we say yes, you have reached max size. And then go out and do the same thing. They're all going to end here. All of these outputs go to here to keep it from locking up and not doing what it's supposed to do. So I'm going to go ahead and cut this video. We'll make another one. I'll try to wrap it up in the second one.